Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as I go through graphing linear functions. So the things that we're graphing today, they're all lines. But before we get to that, we have to have a review of what you would have done in Year 7. Something that looks like this before. Two lines that are perpendicular at 90 degrees to each other. So each of these is just a number line, and you've seen number lines many times before. So these two number lines, when they come together, we call these the Cartesian plane. That is the space in which we are going to graph all of the lines in this topic. So there are two axes. The one going horizontal, lying flat, is x, and the one going up and down is y, and that's always the case. X is always horizontal and y is always vertical. So these are number lines, so they need to be labelled. So where the two axes meet here, x is 0 and y is 0, that's called the origin. That's where the Cartesian plane basically starts. So we can put a 0 or an O there for origin. And then going to the right, all of these x values are positive, just like a number line that you would have seen a million times. On the left-hand side of the origin going across, these numbers are negative. So it doesn't matter that I'm using two squares for each increase in x, okay? And for y, all the ones above the origin are positive, all the numbers, and all the numbers below the origin are negative. So once we've got our Cartesian plane labelled, we can use it to graph lines. So how do we do this? Well, what will happen is you'll be given an equation and you draw up a table of values and then plot a bunch of points. So let's look at an example. So let's say I want to graph this one here, y equals 2x plus 1. It turns out that the graph of this will be a straight line. So how I do this is I draw up a table of values. I draw up a table, I choose the x values, and then I find the corresponding y values. And each time I do that, I've found a point that I can plot. So we'll put x at the top and y at the bottom. So I'm going to choose some values for x. It's important that I choose some negative and some positive so I can understand what the graph looks like in all directions of the Cartesian plane. So I'm going to choose x is negative, and then I'm just going to go up by 1 in each case. So when x is minus 1, y equals 2 times x, 2 times minus 1, because x is minus 1, plus 1. And that gives me also minus 1. So when x is minus 1, y is minus 1. If I substitute in x is 0, then y is 2 times 0 plus 1, which is 1. If x is 1, y is 2 times 1 plus 1. And that equals 3. And hopefully you can see a pattern here. Each time I increase x by 1, y is going up by 2, and that's no coincidence here that it's going up by 2 each time, and there's a 2 in front of the x. So you should see a pattern when you draw these table values. So I can just put a 5 there because it's going up by 2 each time. Now, each of these columns going down, is a point. So this first one has an x-coordinate and a y-coordinate. So I can plot this point on the Cartesian plane. So I go across to x is minus 1, which is here, and I go down to y is minus 1. So that point that I've just labelled in black, that is on the line. Now I go to my next column. So I have x is 0, y is 1. That is another point. So I go to x is 0, up to y is 1, and that is another point there. So I've got 2 points now. Then I do the same. X is 1, y is 3. So I go across to x is 1, I go up to y is 3. And then I have another point and do the same. X is 2, y is 5 would be up here. So all you have to do when you've plotted the points is join them up, and you should see that this lies in a straight line. Make sure you label the line with your equation. Okay, how easy is that? We can do that for all graphs, all linear functions. We get our equation, we draw up a table of values like this, we choose the x value, find the corresponding y value, plot a whole heap of points. And ladies and gentlemen, there you have graphed a line. You've graphed the line y equals 2x plus 1. So what actually is the line y equals 2x plus 1? What it is the set of all the points where the y coordinate is double the x coordinate plus 1. So all of these along here, this is just infinitely many points. This is a whole heap of x and y values that if I substitute into this equation, they make it true. So I want to know now, if this line goes on forever, would the point, let's say 7, 13, would that be on the line y equals 2x plus 1? Okay, so I can tell that pretty easily because I just told you that y equals 2x plus 1 is a line and it is all of the points, all the x and y coordinates that if you substitute into this equation, they make it true. So what I mean by that is this point will lie on the line if I substitute the x value and the y value into this equation and it makes a true statement. So let's do that. So if I substitute y for 13, I get y equals 2 times x plus 1. So I've substituted y for 13 and x for 7. I've just taken this equation, but instead of writing x, I've written 7. Instead of writing y, I've written 13. Now this statement here is not true. 13 is not equal to 2 times 7 plus 1, because 2 times 7 plus 1 equals 15. 13 surely isn't equal to 15. So because when I substitute in these values into the equation, because I get an untrue statement, the answer is no, this point would not lie on the line. Simple as that. All right, I'll do one more example and I'll do it a little more quickly. Please pause and copy down if you need this. Okay, so let's now try and graph the function y equals minus 2x plus 1. Same thing. Draw up a table of values with x and y values. You really only need about 3 x values, but I'm just going to do an extra one just to show you. So we choose our x values. It's good to have some negative, some positive. So I'm going to have minus 1, 0, 1, 2. You can always choose these values that I've chosen if you like. So one by one, we substitute them into this equation here. So if x is minus 1, y is minus 2 times minus 1 plus 1. If x is 0, y is minus 2 times 0 plus 1. If x is 1, y is negative 2 times 1 plus 1, and so on. You see the pattern? Now it's going down by 2 each time. So I'm going to plot these points. So I go x is minus 1 is here, up to y equals 3. Then x is 0, y equals 1. X is 1, y is minus 1. Make sure you're always getting your x's and y's the same way, the right way around. And x is 2, y is minus 3. They should all lie in a straight line. That's what makes this linear. Okay? So that here is the line y equals minus 2x plus 1. Just a couple of things I want to say quickly. Firstly, if the points don't lie in a straight line, then it's not a linear function. So if I have points like this here that go like that, that's not a linear function. It's not a line. The other point I want to make, sometimes you'll have to graph something along the lines of, say, y equals 4. Now here there are no x values, it's just the line where y always equals 4. So to do that, all you do is draw a line straight through y equals 4, like that. Okay, there's nothing else we need to do there. That's the line where the y coordinate is always 4, regardless of the x coordinate. The line x equals minus 3, for example, is similar, but it's vertical. It's the line that goes through all the points where the x coordinate is minus 3. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.